Now we're doing activity 151, part D, in which du over dt equals t minus 1 over t times u plus t squared. And with initial conditions, u of 1 equals 0. Now, something we're going to use during this problem is something from an integration table, which is just basically does a couple steps of the integration by parts for you when you've got x to a power times e to the x. Let's begin. So again, just like all the other ones so far, our first step is to set it up in the proper order. So that means du over dt equals, nope. Let's say plus. And then I'm subtracting this over. Subtracting this over is the same as subtracting is the same as swapping the order of subtraction. So plus 1 minus t over t times u equals t squared. Now I'm going to break up finding the integrating factor. I'm going to break it up into two parts now. So part one is going to be p of t is equal to the integral of 1 minus t over t dt. And now here, the best way to do this is to do, well, that's the integral of 1 over t minus 1 dt. So that's equal to the natural log absolute value of t minus t. Now that means my integrating factor is equal to e to the power of that. T minus t. And that's equal to e to the natural log absolute value of t times e to the negative t, which is equal to absolute value of t times e to the negative t. Okay, so that's our integrating factor, absolute value of t, e to the negative t. That means that u of t, I might have to switch the other 2 pages for this one. U of t is equal to 1 over this, so 1 over absolute value of t, and then 1 over that's just e to the positive power of t times the integral of t e to the negative t times t squared dt. Okay, now I've got absolute value in there. Absolute values are no fun. However, the absolute value of this and the absolute value of that are multiplied together. And so you kind of take like whether or not, if t is positive, this will be just t, and that'll be just t. If t were negative, this would be negative t, and then negatives would cancel out. So that means, thankfully, I can get rid of the absolute values. So this equals 1 over t times e to the t times the integral of t cubed e to the negative t dt. And now we're going to be using our integration table here to do that. So in this case, a is -1, m is 3. So since a is -1 and m is 3, we can just barely kind of fit it in there, equals 1 over t e of t times, so a is -1, so negative x cubed e to the negative t, and then minus a negative, so plus, and then m here is 3 times the integral of x squared e to the negative, oh man, I switched to x's. That's the problem with the placeholders, guys. It's all about the placeholders. Everywhere where you see an X is supposed to be a T, because it's X's in that in my integration table and T's in my problem. So please forgive me for these ugly T's right here. T squared e to the negative T dt. Okay. So let's see if we'll make it to the end of the paper. Probably might have to switch to 2 pages here. All right. Equals 1 over T e to the T times negative T cubed e to the negative T plus 3 times, and then here this becomes negative T squared e to the negative T minus a negative, so plus 2 times the integral of T e to the negative T dt. Okay, and then we've only got one more to go. Then we'll have to put it all together. I'm going to move my equal sign over so that I don't run out of room on the other end of my paper, even though, like I've told you before, generally you're supposed to do like have your equal signs right above each other. It makes it better, easier to follow for the reader, but I don't want the reader to have to be reading my stuff as it like swoops under or something like that. So equals 1 over T e to the T times negative T cubed e to the negative T plus 3 times negative T squared e to the negative T plus 2 times, and then here, this one, there's actually an integration table for that, for just regular that, right here. So that's, forget about the parentheses. So 2 times e to the negative T over negative 1 squared. So divided by negative 1 squared is just divided by 1 times negative T minus 1 plus C. All right, let's see if we can expand that. Okay, every single term has an e to the negative T except the C. So I'll move that up front. So C times 1 over T e to the T, and then so that's the C times that, and then let's deal with our T cubed term first. So our T cubed term is just negative, so minus T squared e to the negative T. The T cubed and the 1 over T become T squared. And then our T squared term here is a negative 3, so minus 3, but then T squared times 1 over T is just T. Negative minus 3 T. No, there's no e to the negative T, because that cancels out. With the positive e to the T. Minus 3T. Okay. And then this is a 2 here, but it's 2 times 3. So minus 6 minus 6 over T. All right, that was messy. And I'm not sure if you followed me all the way with all the mess ups. If if this were on a whiteboard, I could have corrected and ended up with something pretty, at least sort of pretty. But that's the best you're going to get. So now we're almost done. U of 1 equals 0. Well, U of 1 equals 0. So then U of 1 minus 1 minus 3 is 4, minus 4, minus 6 is 10, minus 6 over 1, so minus 16. And so C times e to the 1 minus 16 is 0. So C equals 16 e to the negative 1. Because if that's true, then that cancels out the e to the 1. I'm left with just 16 here, minus 16, and you get 0. So yeah. So then I'll put my final answer. It's not worth it to get a whole second page just to put the final answer one last line. So we'll put our final answer up here. So that's that. So I just need to repeat this last line. So that means that U of t equals, our C was 16 e to the negative 1. So 16 over t times e to the t minus 1. Then minus t squared minus 3t minus 6 over t. All right. So that's just the bottom line here, but with the c, and the c included the e to the negative 1. I just put that inside here instead. So that is activity 151D.